All right, in this video, is another exponential problem. We're going to be solving for y in the equation 10 raised to power y times 5 raised to power 2y minus 2 times 4 raised to power y minus 1 is equal to 1. The first thing we need to do is, don't forget, always endeavor to reduce to the least possible base. So how do we reduce to the least possible base? Let's start with 10. Now, somebody will say 10. 10 cannot, we can't have a common factor that would multiply to give 10. No, it's possible. We can reduce 10 to give us what? 2 times 5. So that's 2 times 5, raised to the power of what? Y, right? Then times, then for this other one, we still have 5 raised to power 2y minus 2. Then times, if you look at 4, we can reduce it to what? 2 raised to power 2 to bracket y minus 1. Don't forget, we could not decompose 5 further. That's why I left it that way. Then everything is equal to 1. So now let's move on. So from law of indices, from power distribution law, so let me just do a recall. Recall, if you have what? Xy raised to power n is the same thing as x raised to power n times y raised to power n. That's what I'm trying to do. So for everything I do, I'll do that recall as possible. So this one will now turn to 2 raised to power y times 5 raised to the power of y, right? Times, okay, 5 raised to power 2y minus 2. Then times 2 raised to power 2 times y, that is what? 2y. 2 times minus 1 minus 2 is equal to 1. There's something we need to look out for here, and we have to be very careful. I will do a recall again. This will really help us. If I have a raised to power x plus y, is the same thing as a raised to power x times a raised to power what? Y. It's very important. That's one of the laws of indices. So that implies I want to decompose this one. So let me bring this down back. We have 2 raised to power y times 5 raised to power y, then times, this one will now turn to 5 raised to power 2y, then times 5 raised to power what? Minus 2. Because they have the same base, I can add the power back just from law of indices, okay? Then times 2 raised to power 2y minus 2. Everything is equal to 1. If you look at this, there's similarity. We can collect like terms. We have 5 here, we have 5 here, we have 5, we have 2 here, we have 2. So we can collect what? Like terms. Collect like what terms? Or in some cases, we can say regroup. So if I regroup it, I have 2 raised to power y, then times which other one? That is 2 raised to power 2y minus 2, right? Then times 5 raised to power what? Y. Then times 5 raised to power what? 2y. Then times 5 raised to power what? Minus 2 is equal to what? 1. So having done that, what do we have? We have 2 raised to power y times 2 raised to power 2y minus 2 times 5 raised to power y times 5 raised to power 2. Then, so from law of indices, pardon me, to make it, if you have what? A raised to power what? X times a raised to power y times a raised to power z is the same thing as a raised to power x plus y plus what? Z. Y is only valid for the same base. So this base and this base, they are the same. So we can say 2 raised to power what? Y, right? Plus 2y minus 2. Then times 5 raised to power y plus 2y minus 2 is equal to what? 1. Okay? So what's the next thing? Y plus 2y, that's 3y. 3y minus 2. So we have 2 raised to power 3y minus 2. Then times 5 raised to power y plus 2y, that is 3y minus 2 is equal to what? 1. Right? So now they have the same power. What can we do? We can distribute it. What am I saying? Recall again, pardon me, that if you have what? A times b raised to power what? N. Same thing as a raised to power, okay, no, let me put it this way. If I have what? If I have a raised to power n times b raised to power n, I can write it as a times b everything raised to power n. That's the logic here. They have the same power. So I can therefore say 2 times 5 raised to the power of what? 3y minus 2 is equal to what? 1. All right. So 2 times 5, that is what? We have 10 raised to power 3y minus 2 is equal to 1. But notice something. For me to be able to eliminate this 10, this other side must have 10. So recall that what? Any number, any non-negative number, let me be specific, raised to the power of 0 is 1. So I can say 10 raised to power 0 is equal to 1. So wherever I have 1, I can replace it with 10 raised to power 0. So I can say 10 raised to power 3y minus 2 is equal to what? 10 raised to power 0. 10 cancel 10. So 3y minus 2 is equal to 0. So 3y is equal to what? 0 plus 2, of course. So y will now be what? 2 over what? 3. So the value of y in that particular problem is 2 over 3. I want to believe that you have learned one major thing or the other. Please endeavor to subscribe so as to encourage me. If you don't subscribe, I may be discouraged. Thank you. I'll be expecting your comment in the comment section. See you in the next video. Bye.